the purpose, the mission of this podcast is to make EV happen, make AV happen. So this is going to be definitely one of the major player in the EV business, in the AV business. So this was really the right thing to talk about. And welcome back to Matrickz Tech Talk. Today we have three very interesting guests all across the Atlantic, all the way from California. First, we have Doug. Here are three things you should know about Doug. Doug was a civil trial lawyer. Then he became a peacemaker. He's an author of 4 books, including an Amazon bestseller. And finally, this Sunday, Doug achieved to make 9,000 vertical feet in 2.5 hours. And Doug is 72 years young. Doug, welcome to Matrickz Tech Talk.
Thank you, Hasan. Great to be here.
All right. Now, let's go to our second guest. I'm super excited. Today, we have amazing people. Mike. Mike has 35 years of experience with custom motor design, and he worked for major US custom motor manufacturers. And what he does is his hobby is to rebuild Corvettes. Mike, welcome to Matrickz Tech Talk.
Thank you, Hasan. I appreciate it.
Finally, we have Noah. Noah studied biology and economics. 12 years ago, Noah founded ClearWater, and this is exactly what we're going to talk today about ClearWater and its mission. 12 years ago, Noah founded ClearWater, which led to the innovation of high-performance, ultra-high-performance electric motor. And last but not least, he's an extreme curious personality. Noah, welcome to Matrickz Tech Talk.
Thank you, Hasan. It's a pleasure to be here.
Amazing. So I want to ask a first question. I don't know who's going to take that question because you're all involved with ClearWater. So before we go with ClearWater, I mean, what was your aspiration to get into ClearWater, to found ClearWater? What was the aspiration? What led you toward this journey?
And Hasan, it began with a development of waste product, high performance, compact waste processing products that need a great deal of electricity. And when we started developing the means to provide the electricity, that led to our focus on ultra high performance, ultra efficient electric motors and generators.
It's fascinating, Noah. What was your, what was the personal story behind it? I mean, what led you to, what sparked the drive to go in this route? We know entrepreneurship is difficult, right? And you founded a company, successful company with innovation. And it seems like, when I see your face, when you talk about these things, your face is lighting up. So you're living your dream. You're an innovator. So what sparked all of this?
Really, what sparked it is, as you said in the introduction, I'm insatiably curious. And the combination of my background in biology and economics, along with my career at the time as an investment banker, one of the things that I realized is that all transportation is, in fact, controlled by the waste that the passengers put in the plane or the train. And so we developed a way to process that waste, but it requires a great deal of electricity. One thing leads to another. My perspective on life is that everything has an interactive and interdependent function. So that as far as I'm concerned, I'm living my dream because everything continues to develop in a fascinating way.
I love that. So who did you found the company with? Were you the sole player, or how did it start?
No, I wasn't the sole player. I have an operating partner, Morgan Harwith, who isn't with us today. And he and I were the co-founders of the company. I developed the technology before he and I met. We became partners. We've developed it to a particular point. Doug was one of our early investors and has really been a primary guide to help me focus on the best way to exploit this. We could not be doing what we're doing today if it weren't for Mike, however, because Mike is the one, given his background and his extraordinary innovation, is the one that has really helped us to bring the fundamental proprietary technology to the state that we have it today, which is unprecedented performance.
Love that. So I'm going to get to Mike and Doug in a second. What really fascinates me that you studied biology and economics, then you work for investment banking, and then you invented a ultra high performance electric motor. How did that happen? You know, where did you learn the mechanics and then the principles?
I didn't. I have to give credit where it is due. I am not the original inventor of the technology that this is based on. What I did was have the very good fortune to be introduced to another electrical engineer who was the one who invented the original architecture. We have continued to refine that. I've made my contributions to it. And one of the really fortunate things for me is that Mike and I have the kind of relationship where I can have one of my crazy ideas and Mike can either tell me it's not worth pursuing or he takes it over and develops it. It's a very synergistic relationship.
So you had the idea of doing something like this, and you found an electrical engineer to kind of like work on your idea, or was it that the electrical engineer already had that idea? How did these two meet?
What I brought to him was a concept and an approach, and what he did was to refine it.
Gotcha. Fascinating. And I'm gonna ask you about that concept in a second. Before that, I will go to Doug and say, Doug, I mean, you're an investor in this company, and I mean, I can see that these two gentlemen here, they're really, really passionate about it. What did you see in this company? Why did you invest here?
Well, it was an opportunity to get in a startup that wasn't based on software computers. It was based on something far more foundational, which is electricity generation, electric motors. And the technology is unbelievable. I mean, it's unbelievable how it's almost magical. I'm not an engineer, I'm a lawyer, but what we have developed is unprecedented. And I've been very excited about it, especially now that we're about ready to go to market with it. And I saw a way for us to develop a technology that could literally change the world. I mean, we could stop 33% of all greenhouse gases using our technology.
Love that. So that brings me to Mike. Mike, can you explain the technology that we're talking about so that a 5-year-old can understand?
Well, Hasan, I'll try. I'll do my best. So I got involved with ClearWater a couple of years ago. And primarily, my background is taking concepts. I am a concept guy, but I'm more of a hands-on guy who does detail work to actually productionize ideas and concepts. But to try to put it simply, what makes the ClearWater technology unique is the fact that it uses an a radial axial radial combination of 3 fields within the motor itself. And the combination of the 3 fields harmonizing and working together is really the key to the high efficiency and high torque densities that we can accommodate with this technology. and that's as comparing with your standard radial technology and axial field technology that's out there in the marketplace today. So it's very, very unique. And the reason I got involved with it, once I saw the concept, I knew that this was something different and could actually achieve performance levels that were unattainable in the past.
So if I understood it right, I mean, you're talking about harnessing the 3 fields, right? Now,
Correct.
for our audience who are not familiar with the mechanics of a motor, let's go back to very basic. If you think about a motor designed by Faraday, can you explain to our audience a little bit how Faraday's motor work, the very basic principle, and what are the steps, what are the deltas toward your one if we compare to the ones we know from high school?
Right. The Faraday's motor is based on the chasing field theory, where the rotor is chasing the stator field, and that's how you produce torque. Correct. And so, in a typical motor, you'll have one rotating field. And in our application, in our technology, we actually have 3 rotating fields within the same magnetic circuit. So the benefit is you can sum the torques of those 3 fields and actually achieve higher torque densities and higher efficiencies as compared to just a single field simple motor that we would run back in high school in our old electric shop classes. So
if I mean, forgive me if I'm like totally messing it up. So are you saying that, so in case of regular motor, we'll have one of those things rotating. Now we'll have 3 of them rotating.
They're rotating, though they're on the same shaft, right? And so on the same rotor. So you'll have a radial, basically a radial field on the inside of the stator. You'll have an axial field on the side of the stator, and then another radial field on the OD, rotating around the OD of the stator. And that's how we achieve our 3-field arrangement. And again, you have three unique torque-producing air gaps within the 3 fields. And by doing that, that's how you're able to sum those together and actually create, again, higher torque densities within the same package size as compared to existing technologies today.
Let me see if I can, as a lawyer, sum it up to the jury. In a typical electric motor, if you take a motor apart, you're going to see that it's got all kinds of wiring in it. That's called a field coil. All right. That creates one magnetic field that when you apply electricity to it, it rotates, it drives the rotor, the thing that spins, the motor part of the thing. Those magnets react against the magnetic field and they spin. You got a lot of problems with that kind of a motor. One is heat, where you get a tremendous amount of heat that lowers the efficiency. 2, you've got a coil, and if that coil breaks, any part of that wire, it's one long wire, and if any part of that wire breaks, the motor fails. It's totally useless. And you've got the problem is as the field rotates, the magnetic field rotates, you got gaps in the field where it's driving and then it's not driving. It's driving, it's not driving. If you can imagine having 3 different kinds of magnetic fields that we've been able to develop that are essentially perpendicular to each other, we eliminate all of those problems. And when we don't have the coil, if you look at our motor, you will not see a lot of wiring in there. In fact, we use about 66% less copper in our generators than a traditional motor. The way we've been able to achieve that is through architecture, through designing it so that if you can imagine 3 magnetic fields able to rotate together, that's what creates the efficiency. It's very unique. There's nothing out there like it.
Got it. So it's not 3 different rotators. It's the 3 different magnetic field and 1 rotator. And why do you do not need a coil?
Well,
No,
we have coils, but they're very, I'm not going to get into the technology because it's proprietary, but we have a way of setting up coils, but instead of having one coil, we have multiple coils. And they're quite small and they're modular. So that we can actually create, we can turn the coils around, we can put them in different alignments to get these three different magnetic fields going.
I get it. Wow. So, in case of a regular one, they will have one, for this magnetic field, they'll have this, but now they're getting one torque here, then the second magnetic field gives given another torque, the third one is giving another torque. So it's like at least 3 times more push to dumb it down to, simple words. But I love that. I mean, it's a genius idea. Wow. This is amazing. And now, in which field is it like, currently in application? I couldn't help asking this question already.
Well, we're in discussions with EV manufacturers because obviously it has a direct application in all kinds of transportation, whether it's scooters, three-wheelers, big trucks, cars, buses, it doesn't matter. Aerospace for airplanes, the power to weight ratio is so huge that it gives a huge advantage over existing technology. Without changing battery technology or controllers or anything else, we can extend the range of any electric vehicle by at least 33% with using our technology.
Gotcha.
So if you've got a Tesla that has a range of 280 miles, you put our motors in and you're gonna add 33% to that. Another 70 miles, you go up to 450 miles with the same motor, changing nothing other than the motor. That's part of the technology, and it's much smaller and much lighter.
Yeah, that would add up to some of the performance also.
That's
All right. So what is like it's been 12 years, right? So what has the journey been? How the journey has been, like, you from developing and are you ROI positive? Are you cash flowing, or what stage of this development? I mean, 12 years is a long time. Can you tell us about?
Hasan, your question is an important one, and the fact is that 12 years is a very, very realistic time frame, considering that what we have done is, for all intents and purposes, reinvented the architecture of electric motors and generators, so that the 12 years has been spent in refining. We started out with the original architecture, but that architecture, every time, and listening to my colleagues, both Mike and Doug, is fascinating to me, because one of the things that I think is true for all of us is that as we work on this technology, we continue to realize that it has applications and opportunities that we really hadn't conceived of until that moment. So that Doug, I think, very adroitly built on what Mike had said technically. The additional focus, and this occupied part of the 12 years, was beginning to realize what are the best ways to use this technology. Doug's reference to electric vehicles is really very important, because our technology because of its performance capabilities, can be adapted to any kind of a drivetrain, whether it's a central drivetrain or hub motors. At the same time, because of the architecture, what we have is simultaneously a motor or a generator, so that we can take the same architecture, and rather than applying it to electric vehicles, we can apply it as a generator to the production of electricity. And as Doug was referring to in terms of increase in range, now what we're doing is decreasing by, again, about a third. We're decreasing the greenhouse gas emissions because of the efficiency of the technology. And by the way, I want to point out, I want to point out something that has been referred to by both Doug and Mike, and that is that the efficiency level we have achieved is 98.4%. That is totally unprecedented in terms of any motor or generator technology. It's extraordinary. And at the same time that we're doing it, as Mike would describe, at the same time that we're doing it, we're producing an extraordinarily stable and very, very high torque production. It really is extraordinary technology, and taken as long as it's taken. You know, in part, that was because of the way that I decided to develop the company and supported by our investors. And in part, even if we had been a huge company, it still would have taken about the same amount of time. It's just that we spent a heck of a lot less in doing it because we did a lot of hands-on work and learned a great deal in the process.
Hasan, let me explain it this way. Imagine you got an emergency situation and it's a flood situation and you need a generator and you need a pump. All right, so you turn on the machine with an electric generator. Now you're generating electricity, but now wait a second, I gotta pump out this emergency place where all this water is. Flip a switch, it now becomes a motor that drives the pump. That's what we mean when it's both a motor and a generator. All you got to do is flip a switch and add power to it, and it becomes a motor. And it's literally a matter of flipping a switch.
Love that. Now let's talk a little bit about the technicality of it. You know, you nicely mentioned like you have three magnetic fields, and this is how the efficiency or the net torque is multiplied. So Mike mentioned like some jargons like radial, axial, radial topology. Can you explain that a little bit, Mike, so that our audience follow what you're talking about and why exactly is it so efficient? Is it because of this topology, and what's so special about this? What is it actually that you're talking about?
Yeah, and Hasan, I'll try to be a little more clear this time on what the technology is. And Doug had mentioned before, you know, you basically on a standard motor, you basically have one field that's rotating inside a stator or sometimes outside a stator, just depending upon the configuration of the motor. And so when I describe the radial, axial, radial topology, what that means is there's actually on one rotor, there's actually three fields, three permanent magnet fields on that rotor. One is radial on the inside of the stator, one is axial on the end of the stator, and then there's another radial one on the OD of the stator. Okay, and all three of those fields are rotating around a stationary stator all at one time. And that's in comparison to a standard motor technology that's out there today that only has one magnetic field rotating. And so the key is, I mean, the real secret of the secret sauce here is to take those three fields and harmonize them together within one magnetic circuit so that all of these fields are, instead of opposing one another, all working together and creating torque within three distinct air gaps within this radial, axial, radial configuration. It's kind of a complicated topology to try to explain, but that's kind of it in a nutshell. You basically have three fields instead of one, and those three fields tend to sum the torque levels, which that's how you achieve the higher efficiencies and higher torque densities.
Love that. Love that. You know, that reminds me when I was a child, I used to, you know, break a toy car and get the motor out of it. And there was really two magnets, you know, permanent magnets that you mentioned. Now, just to play with it, play with the idea of this, in that little motor, on top of those two magnets, what you would do is put another one 90 degree, like, you know, orthogonal to that, and another one on this side orthogonal to it. So this is I know this is much more complicated than that, but that's the idea. Is that
In
the right
general,
way of thinking?
yeah, Hasan, in general, you're right. You basically are right on. And yeah, without getting into all of the, the hardcore details, I mean,
Yeah.
I think that's a good analogy that you just mentioned.
Wow. And so like you have so much of efficiency, and like you have like your 33% more, you're generating 33% more of electricity or range, whatever you want to call it. So what is the reason for this efficiency and the output? What is, like, I mean, one thing that I understand, that you're summing up the magnetic energy, you're kind of like, aggregating the magnetic energy, or, so the effect of the field to generate more torque. Why is it so efficient?
Well, because you've got three fields versus one, and in those three fields, you actually sum the torques in those three fields. So that summing is what achieves the higher efficiency in the same package size. And really, that's it in a nutshell.
Gotcha. So when I talked to Doug, actually in our first conversation, the way I understood is that you would be, your business model would be, you will be giving out licenses. You would not go in manufacturing.
That's correct.
That's correct.
Right.
So what's the current state of the commercial stage of this company? Where are you commercially? Have you, are you like, what's the cash flow situation right now?
The company is pre-revenue. The development period has led to where we are now, and it's really only been very recently that we began to expose the technology for the purpose of licensing it, either to transportation companies or to distributed electricity producers. So our approach is to create that license arrangement for a particular application, for a particular territory. And then, because we understand the technology, and as I think it's apparent, it is very complex technology to fully appreciate. So that once that threshold of understanding of its value is crossed, and we can create a license relationship, then we make ourselves available as initial designers of the particular application, whether it's as a motor or as a generator, or as Doug referred to, a motor and a generator in the same device. We're right now beginning those negotiations. I'm very optimistic that the people that we're talking with have the wisdom to see the extraordinary value of what we can provide. And I'd love to revisit you, Hasan, in a very short period of time, and describe to you the specific licenses and applications that we've entered into.
I think I can elaborate.
Love that.
I can elaborate a little bit more, Hasan, without divulging confidential information. We're in negotiations with a company that appears to be operated by another entrepreneur who sees a competitive advantage in a very crowded market, and he sees our technology as something that will explode his business into all around the world. And we're in very serious negotiations for licensing him to manufacture motors in his home country that he will initially probably install in motorbikes and motor scooters, and then transition to four-wheel vehicles. And he expects that if we do what we say we're going to do, that he's going to blow the socks off his competition. And
I believe so.
And
so, yeah,
go ahead.
please.
Hasan, if I may add to that, I think it's very important to focus on something that Doug said in passing, and that is that anyone who uses our technology is really getting an extraordinary competitive advantage. Whether it is because they increase their range by a third or more, whether they are able to reduce their battery pack by so that they can balance both their desire for range and the reduction in sunk cost, or if they're producing electricity, they can locate the production of electricity at where it's needed rather than a dependence on the grid, and at the same time reduce the consumption of fuel. So that the competitive advantages of the technology are really extraordinary. And I want to point out that we have just filed provisional patents on a genset technology that really takes all of the production of electricity to the next level. It's half the size of conventional gensets. It reduces the amount of copper, which is a very, very significant natural resource. It reduces the amount of copper used in the production of that genset by 90%. It still achieves a 98% efficiency. And because of its architecture, it's operating with less vibration and less noise so that it can be located in places that right now require very expensive installation facilities.
I love that. So now I want to touch some of the points that is relevant for the audience. My podcast is known as the Autonomous Vehicle Safety and Security Podcast. So the audience, they are interested in the safety and security aspect of it, and I can see the automotive, unfair advantage, so to say. Whoever will adopt this technology, this is gonna be a big leap. I mean, 33% is huge. Now, as you know, that when it comes to automotive, you have to have certain safety norms and stuff. Have you done any preliminary studies or any measure to demonstrate that this would be safe enough for automotive?
Well, I think that one of the things that is most important is something that both Mike and Doug referred to, and that is that the architecture, because of the architecture, we differentiate from virtually all other conventional motors that are used in EV. So that in the event that a conventional motor loses one wire in their coil system, you have a catastrophic failure. That's not a very good thing to happen when you're going at high speed on a highway. Because of our modular architecture, we preclude that. Simply can't happen. So that the reliability of the technology, the ease of its maintenance is also very, very significant in terms of EVs. This is as complex as the architecture sounds, and it is indeed complex. It is actually very, very simple to service. Much easier, much less expensive, and much more adaptable than any conventional electric motors that are used in current EVs. Mike, would you add to that, or are there things that I've left out or that should be emphasized?
Sure. Hasan, basically we have a coil system where they're all individual coils. Typically in normal motors that are presently used in the industry, especially in EVs, and I assume that's what we're talking about here. They're typically three-phase machines, and each phase, all the coils are tied together in those typical topologies. In our topology, we have individual coils that are uniquely interconnected such that they're independent. So when you lose one coil, you do not lose the whole phase. So in a conventional motor where you, as Noah had mentioned, if you lose one wire, you have a short, you typically will lose the entire motor, which is not a good thing. In our design, if we lose a coil, we do not lose the entire phase. We will have diminished performance, but we will not have a catastrophic failure, and that is the difference.
Amazing. So at least from the topology wise, it even seems safer. Safety is one of the very important things in automotive. So that really is exciting, and because if you're modular, then you're not depending on single point of what we call in safety single point of failure, right? It's still going to work. I love that.
Another safety factor that we haven't talked about, and that is that we eliminate the mechanical transmission. Because of our coil system, we have a continuously variable electronic transmission, and we control it all electronically, so that the need for mechanical transmission goes away. And that's another failure point, and another very expensive, heavy piece of machinery that most EV manufacturers have to deal with. They've got to take a motor that's running at 15 or 20,000 RPM, and they've got to reduce it down to a tire speed. We don't have to do that with our technology. Our motor runs at 2,800 RPM, and we can torque it down to 2 RPM, using the electronics inherent in the design.
And what is your the magnitude of it? Are you only thinking of EV size motors, or can you also imagine motors are there?
We can go from biological size motors that could be little pumps all the way up to 1 megawatt and above.
Wow.
It's completely scalable.
1 megawatt and above. So, I mean, there is no limit.
Not that we haven't built a 1 megawatt motor or a generator, but we don't think there are any limits, really, practical limits. There are practical limits, of course, but technologically, it's totally scalable.
I mean, imagine if we just use your generator in all the wind turbines in Germany. It's a 33% gain. I mean, our energy costs are, because of all the political things that are happening, is going over the roof, right? So, I mean, energy politics in Germany is another thing that probably we don't want to talk about. But, we need such technologies. We do need such technologies.
Think of it this way. We have a generator that's going to use 33% less natural gas to drive.
Yeah, everywhere. Yeah.
And if you take that generator and then use it to power one of our motors, it's going to take 33% less electricity to get the same amount of power out.
Right.
So between the generator and the motor, there's a huge savings of electricity and power, and the prime mover power you need to turn the shaft.
I love that. So, how, if somebody's interested, in this, I'm pretty sure many of my audience will, because my audience are primarily automotive people. I'm pretty sure it's amazing also for the German auto manufacturers. If they want to get in touch with you, how do they get in touch with you?
They email me, Hasan, at Noah, Noah, at 360powergroup.com.
Gotcha.
360powergroup.com.
All right.
And I would love to hear from anyone who is interested, and anyone who has questions about, well, can it be applied here or can it be applied there? That's the kind of conversation that we want to get into, because our technology has such a broad range of applications. When Doug was referring to its range from biomechanical and biomedical up to 1 megawatt or larger for electricity generation, or for in horsepower generation, going from, as Doug mentioned earlier, a bike or a scooter up to very large freight trucks. They're really, and that's another aspect of the technology, is that it is directly scalable. And in scaling it from that small size to a very large size, we effectively maintain all of the performance attributes that we have been describing. It really is very extraordinary technology. I'm very excited at the opportunity that, Hasan, you've provided us to describe what it is that we're doing and how it might be used.
It is totally worth describing this technology to my audience, because this is exactly the right audience. And the purpose, the mission of this podcast is to make EV happen, make AV happen. So this is going to be definitely one of the major player in the EV business, in the AV business. So this was really the right thing to talk about. And thank you so much for being here.
Well, thank you.
Thank you.
Thank you,
very
Hasan.
much.
Thank you so much. So thank you so much for watching this episode. If you have any questions, comments, please feel free to write in the comment section. We would love it if you give us a thumbs up and subscribe to our channel. So see you in the next episode.